this talk, I'll be presenting two basic issues. I'll be talking about the computing, an introduction, and as well as I'll be talking about introduction to networking. And both these topics are very much there in your CS 611, the computer fundamentals course. The basic objectives which we have foreseen for this particular task are to introduce you to the basic hardware terminology. I would also like to introduce you to some of the software terminology, which includes the operating system, a brief introduction where I will be covering some of the major terms, and then I'll be talking about networking and its applications, and I'll be specifically dealing with TCP/IP because that is one thing which has come up after what your course has been introduced. It has come up at that similar point of time, but I would like to give slightly more general view of TCP/IP for you in this particular session. To begin with, what we define a computer system to be? Well, if I want to define a computer, what is the first thing I would like to define about the computer system? And the first thing we would like to define about the computer system is the instruction. What do we mean by instruction? Instruction is a binary coded command for specific task, such as arithmetic and logic operation, looping and decision making, transfer of data and transfer of control. Now, all these four operations are quite primitive in nature. That means a computer which is basically an instruction executor performs very simple operations, which may be like transfer of data, transfer of control, performing some of the other related operations, arithmetic, logic, conditional, looping, those kinds of operations. But how do computer execute these instructions? Well, it's a five-step process which includes get the instruction, decode the instruction, get the operands, perform the desired operation, and communicate the results back. If these are the operations, how these operations are performed? Obviously, we need a typical configuration of a computer system, and that configuration of computer system, which was first designed by von Neumann, is called a von Neumann machine. Let us look into some of the basic components of von Neumann machine, and then we will go back to instruction execution. Now, this von Neumann machine which we are displaying over here, what you can visualize here is there is an arithmetic and logic unit. This is input-output system, which basically communicates instruction, data and everything from here through the CPU to main memory. Main memory is the memory where all the instructions and data get stored at the time of execution. So it includes instructions and data. And this is the control unit. ALU and control unit constitute the basic central processing unit of a computer system. But what are the basic components of arithmetic logic unit? An arithmetic logic unit basically can consist of the logic circuits, arithmetic logic circuits. The purpose of these circuits is that these will be used for addition, subtraction, doing a logical AND OR kind of operations. AC is an accumulator register which basically interacts with the arithmetic logic circuits along with memory buffer register, which stores the content of whatever content are brought from the memory are stored into the memory buffer register. So it can also be sometimes treated as data register. An accumulator is the one where the results also go after the execution. So accumulator is basically the primary source of or where the instruction execution takes place. Now, what are the components of the control unit? Well, control unit consists of something called instruction register, where the instruction comes. Okay, so instruction reaches to instruction register, gets loaded over there. MAR is an interface. It is called memory address register, and it stores the address of whatever is to be fetched from to the memory. It can be data or instruction. As far as control unit is concerned, if address has gone to MAR, it simply is put onto the address bus, and the related data or instruction, whatever is stored onto the location, is fetched to either ALU register, that is MBR, or through MBR to instruction register. PC happens to be another register which is program counter register, and the objective of this register is to store the current instruction address which is getting executed. So if you want to go to the next instruction to be executed, you simply can increment PC and can go to that particular instruction. The rest everything is control circuits, which basically issues control signal that relates to when data is to be fetched, when an execution has to be performed as far as ALU is concerned, which operation is to be performed on data. All that information is passed on by the control circuits. So now let us try to understand how an instruction gets executed. Now what is the first thing, if you remember what we had as far as instruction execution is concerned? We had get the instruction. Now getting the instruction, where exactly the instruction is residing? Instruction is residing somewhere here in the memory. So instruction, you want to get the instruction into the instruction register, only then it will be interpreted and related control signals will be executed. That simply means whenever an instruction is to be fetched, that may be the next instruction to be executed, the address of that is residing into the program counter register. So PC passes that address to memory address register, which in turn applies that address onto the memory. The related instruction is fetched under the control of control circuit signals. It is fetched to MBR and passed on to instruction register, because this is an instruction. As soon as the information reaches instruction register, what we say, the instruction has now been fetched, or the first step has been completed. The next step will be to decode the instruction. Now where exactly the decoding is going to take place? The control circuits are going to decode the instruction. How they are going to decode the instruction? The operation code of the instruction will be used to determine where exactly are what operation is to be performed, and in addition the rest of the instruction will be used to determine where exactly are the operands and how to get that. What will be the next step after decoding the instruction? Get the operands. Now getting the operands, once again the address of the operands, part of which may be residing in IR, part of which may be residing in MAR. If it is residing in IR, it will be passed to MAR, or if it is residing anywhere in any other register, it will be passed to MAR, and similarly that particular data value will be fetched to MBR. What is the next step? Next step is perform the desired operation. Where exactly that operation will be? Once the data is received in MBR, suppose it was an addition operand, then accumulator is supposed to be one of the operand. Second data is obtained from MBR. Both the data values are added using arithmetic and logic circuits, and the result is passed on to accumulator register in that particular operation. So result at present is stored in the local location. Now to get the result, communicate the results back. To get the results back, what operation we would like to do? We would like to store the content of accumulator register into the address location wherever which has been pointed to by MAR. So MAR not only points to the addresses which are to be fetched, but also points to the memory location which are to be written with the content of location or some memory location or some register value in this particular thing. So in nutshell, this is what is the task of instruction execution which is performed by the central processing unit of the computer with the help of main memory. And main memory is the one where all the program and all other data resides. Input-output device communicates all the information whenever we want it to communicate. Okay? So this is the way instruction execution takes place in a computer system. Now what are the major components of the computers? The processor is the first one, and if you are talking about the processor, what you need to talk about the microprocessor. What is a microprocessor? It is nothing but the whole processor built into one particular unit. Okay? The processing speed, you talk in terms of megahertz. You might have heard about the Intel Pentium processor with the speed of 1 gigahertz. Now all these things are the processor speed related thing. Third important thing which I would like to share with you is RISC processor, reduced instruction set computers. Those processors are supposedly very simple type of processor where the instructions are very simple, and they are used in today's computers because they enhance or they overall performance of the system. Well, how can they enhance the overall processing of the system? For the basic simple reason that if your instructions are simple, if your addressing modes are simple, if your operands are following a particular or are in the registers, then execution can be done in a pipelined mode, which is much faster than your general way of executing instructions. And that is why in your processor I wanted to cover the term called RISC. Anyway, now coming back to the von Neumann architecture. If we want to talk about von Neumann architecture, what we have talked about is the central processing unit. Is there any other component which we have talked about? Yes, the memory, the main memory of the computer. Now the question which is asked is, what should be the size of the main memory thing? Well, one basic rule in that is designers want large capacity but low access time as far as memory is concerned. Overall memory system of a computer is concerned. Designer wants a huge capacity, maybe running to 20, 30, 40, 50 gigabytes. But they also want low access time. If you have a hard disk, it has a very high access time in terms of milliseconds. As far as CPU is concerned, it talks about in terms of nanoseconds. So what do? You simply employ something called memory hierarchy. Now what is this memory hierarchy? What is it all about? Memory hierarchy is nothing but you employ a hierarchy of memories. The smallest, the fastest, like that. I think this will be very clear to you if you look into the diagram. At the topmost, you have registers which are within the processor. Then you have cache memory, which is in today's processor, if you are talking about Pentium, then you are talking about two types of cache. L1 which is within the processor and L2 which is outside the processor. However, the basic purpose of cache is it's an interface between the main memory and the registers and increases the speed of main memory to a great extent. Then you have disk cache, which may be some area into the main memory, or many magnetic disks today are equipped with something called disk cache, where the recently accessed blocks are transferred. Then you have magnetic disk, which is slowest, and followed by magnetic tape, optical disk, which are even slower than this magnetic disk. Now look into the hierarchy. What is the hierarchy? Registers are fastest within the CPU but are small in number. Cache is bigger, maybe in the range of 256 to 512 KB. Okay? Main memory is even bigger, in the vicinity of many MBs, 128 MB, 256 MB, a factor of 10. Disk cache will be very limited because disk cache is not supposed to be very, very huge, but it may be at least 10, 20, 30 different sectors which can be there in magnetic disks. I mean, the basic idea is it will be smaller than the magnetic disk, but definitely equivalent to main memory in some sense, although in case you are using only the main memory for disk cache, then it is going to be smaller than the main memory. However, magnetic disks are going to be very, very big, huge capacity in order of 20, 40 gigabytes, and magnetic tapes in the vicinity of 200 gigabytes or even more. So you have very, very increasing. The access time of register is the smallest, whereas the access time for magnetic tape is happen to be the largest. So this is the kind of memory hierarchy which you must employ in any system. Now what are the key features? As you go down the hierarchy, what you witness, it decreases cost per bit, it increases capacity, increases access time, decreases frequency of access of memory by the CPU. Now this is the most important thing. As you go down the hierarchy, obviously what you witness that the accesses to that particular, for example a hard disk, not the complete area of the hard disk is to be accessible by the CPU at the same time. Only a portion is to be accessed which is brought into the main memory, and then from main memory through cache to the registers, right? And the principle of this kind of a thing is called locality of reference. What is locality of reference? During the course of execution of a program, memory references by the processor for both instruction and data tend to cluster in specific areas. And the main reason for this particular clustering is iterative looping in programs, subroutine functions in programs, use of data structures such as array in data. Now all these things basically boils down to saying something to us, that is, we need to have memory hierarchy. If we do not have memory hierarchy, then what we will be ending up, a very expensive memory which may not be required all the time, and this has been proven by locality of reference. Now there are two basic types of semiconductor memories. One is called RAM, another is called ROM. Now what is RAM, what is ROM? That is what we would like to explore further. Well, RAM technologies can be classified as dynamic RAM, which is called DRAMs, where cells store data as charge capacitor. Now this is the technology, required periodic refreshing. If we don't want to deal with these two information, what we need to know is DRAMs are slower, however they are cheaper, and that's why you go for very huge DRAMs, and this is what is your main memory. Static RAM or SRAM is traditional flip-flop type, logic gate configuration, no refreshing is required. These are as good as what is the speed of your CPU. There is a gap of around a factor of 5 to 10 times slower. This particular dynamic RAMs are slower. Static RAMs are as fast as your processors, and that's why cache are made of static RAM, whereas main memory is made of dynamic RAM. Now let us try to contrast static versus dynamic, or DRAM versus SRAM. DRAM is more dense, less expensive, but require circuitry for refreshing. DRAMs are slower than SRAMs. For large memory, DRAMs are preferred. For small, faster memories, SRAMs are used. So ultimately it boils down to the same similar logic. What is that particular logic? The simple logic is that DRAM should be used for main memory and SRAM should be used for cache. Now cache memory basically is built from SRAM technologies. Level 1 cache or L1 cache is built into microprocessor. Level 2 cache is normally external to the microprocessor, and normally it is within the motherboard of yours. Many people have questioned, why do we need L1, L2 kind of cache? Does it increases? Yes, it just increases one more layer, but it definitely helps in increasing the overall capacity, processing time of a computer system. How does cache work? Cache simply works that the main memory contents are cached into the cache memory, whatever is most currently being used by the processor, and that's how it increases the overall effectiveness of main memory access. This cache is used to speed up access to data on a disk. A portion of RAM called soft disk cache or a RAM as part of hard disk, which is called hard disk cache, which is more expensive, can be utilized. So disk cache is nothing but to increase the overall input output from a disk. Why do we need to increase the overall input output from a disk? Well, disks are the slowest device of all these, and they are 10 to the power 3 to 10 to the power 6 times slower than your processor. In addition, in all computer systems, what you need is something called interconnection structures. Now, what do we mean by interconnection structures? They are collection of parts collecting various modules such as memory, input output, and CPU. So they are the parts. Most common interconnection structure is bus and multiple bus structure. Now that's a very, very surprising thing. What is interconnection structure? Where do we see that interconnection structure onto my computer? Well, interconnection structure can be seen by you onto your motherboards. You might have witnessed that the motherboard, wherever the motherboard is there, you see very thin lines which run across the central processor chip and memory chips and the hard disks and all those other connecting devices you put. All those things are bus. And one of the most common bus which you use in microcomputer is the PCI bus. Most of you must have heard about it. Now let us try to elaborate on one more topic, and that is the operating system. Now what are the basic objectives for this particular topic? To make the computer system convenient to use. In fact, these are the objectives of the operating system. To use the computer hardware in an efficient manner and to increase the efficiency of resource utilization of a computer. So these are the basic objectives why you would like to use an operating system into a computer system. What we had or what we described initially was the basic hardware. Now that basic hardware consists of just the arithmetic logic unit, the control unit, which constitute the processing unit, the main memory, and the input output devices. All those things can be utilized efficiently only if they are operating under the control of this particular operating system. Now what can be an example of operating system? Unix is an example of good operating system. Linux is an example of another good operating system. Windows NT is another example of operating system, and Windows 95, Windows 2000 are example of operating systems. Now what do operating system do? There are four basic tasks: processor management, memory management, device management, and file management. If we look into these four different things, what we can say about operating system? It's a manager. What does it manage? First, the processor. What are the things which are to be managed in the processor? Well, the things which are to be managed in the processor is, when you are dealing with a computer, there can be multiple programs which you can run in parallel. For example, in Windows 2000 or Windows 95, you can create many tasks, right? All those tasks are running in parallel. Now, which of those tasks are to be executed first? which of them can be run in background and processors can be allocated to it? That is the task of operating system. So operating system will determine how much time of processor is to be given to various things. Sometimes operating system can pass on control to you, and by which you can make some of the tasks as most current, which you do in Windows 95 kind of operating system. But it is not necessary that all the time those kinds of things or those kinds of controls are passed on to you. The second thing which operating system do is the memory management. Now what do we mean by memory management? After all, you have 256 KB of memory, not beyond it. If you have that much memory, 256 MB, let's say, out of that, some of the portion will be given to the operating system program itself. Some of the portion is to be given to various tasks which you have created. One of them can be browser, another can be Word, third one can be Excel spreadsheet. Who does allocation of those memories to these tasks? The operating system. Device management. Many of you might be connected to the single printer, and all of you suppose give a print task at the same time. Who is going to determine that all those printing sequences are different, correct? There is no overlap, and all of you get your printouts. Maybe somebody gets it earlier, another gets it slightly later. But it's not that there is an overlap, that one page is being printed for somebody else and another page is being printed for somebody else. Or maybe to the extent one line is being printed for somebody, another line is being printed for somebody else. You get your printouts in whatever sequence you have given. Who does that? Operating system. Management. Files. You create so many files. Who allows you to deal with, place those files, copy, tackle those kinds of things? Once again, the operating system. So operating system is nothing but a major manager of your system. Now, one of the things which we always talk about in the operating system is multitasking. What is multitasking? It supports concurrent execution of two or more active tasks, processes, maintains code and data of several processes in memory simultaneously and multiplexes processor and I/O devices among them, supports memory protection facilities for resident processes. So these are the three basic issues with which your operating system deal with when you have opened multiple windows. Another operating system which has found popularity is multi-user operating system. Now what is multi-user operating system? It provides facilities for maintenance of individual user environments, user authentication for security and protection, per user resource usage accounting. So all these information, all these things are controlled by the multi-user operating system. Lastly, but not the least, one of the major mechanism which comes as far as operating system is concerned, these days we talk about threads. What is thread? Well, thread is a lightweight process or task. It results in improved performance. A group of threads share resources such as memory and files, therefore can communicate efficiently through shared memory as the memory boundaries are not to be crossed. Threads are used in implementing network server. Now these are some of the basic points which you deal with threads. What you can think of as far as threads are concerned, you understand the process. If a process can have multiple instances within itself, then there is a possibility of multiple threads going on. For example, a print server waiting for multiple processes, multiple print jobs, and threading them. In fact, print server may not do the multi-threading kind of a thing. However, a network server would like to do that kind of a job. Okay. So this is in a nutshell what I wanted to talk about, the basic issues dealing with operating system. So what we have covered by now, the basic issues relating to von Neumann architecture, some of the component of it, instruction execution. Then we talked about the operating systems, its functions, and some of the major concepts in operating system. Now let us move on to the third important thing which we do in CS 611, and that is networking, introduction to networking. Now let us look into what are the issues relating to computer networks. Now the very first thing which I would like to share with you is, what do we have? What are the typicalities when we put signal on wire? An electrical signal gets reflected from end of a metal wire like light from mirror. That simply means network requires terminator at every wire. Most of the time we are confused. Why there is a terminator? This is the reason. Electrical signal lose energy as they pass through wire. Length of interconnecting wire is limited or amplify signal. Otherwise you need to amplify signal if you are not using a limited length connections. Third, electrical signal in a wire emits electromagnetic radiation. So use shields. All these three things give us lot of good pointers. What kind of pointers they give us? That network terminator should be there. The wires which we are using should be either away from the electrical wires or should be properly insulated if you are doing cabling for the networks, right? And if you are laying cables, you need to see that it does not go beyond a particular distance. Otherwise, if you have not placed the amplifier, you will not get the right kind of signal. Okay. What are the other things which are there in the network? Well, another important issue is information coding. Modulation, demodulation on the basis of oscillating signal called carrier. This is what you do in analog digital signal. Dial-up modem contains additional circuitry that can dial a phone number or can receive it. ASCII code is the most popular code across the network industry. And in addition, you also have digital means of passing signals, the digital signals, and one of the most common way of coding it is Fourier transform. Anyway, that is beyond the talk, this particular talk. So let us move on. What are the other issues in a network? Other issues may be detecting errors. After all, when a signal is being passed from one place to another, there are going to be certain errors. How to detect those errors? To guard against corruption of information caused by electrical or magnetic interference, error detection and correction mechanisms were devised. So all networks have error detection and correction mechanisms. One simple technique is adding a parity bit in the data. Now parity bit information, or in the more general terms, what you carry is CRCs, cyclic redundancy checks kind of codes in most of the communication devices. But why do you want to go for networking? What are the basic logic? Why I should go for networks and networking thing? Well, the main reasons are price to performance ratio. Cost reduction is due to sharing of hardware and software resources, use of low-cost microcomputers rather than mainframes, and increased productivity is due to sharing of data among users and message passing. So basically this is price performance ratio is much higher in this particular case. Next advantage is high reliability. It replicates data at more than one place. That's why you get high reliability. Scalability, incremental growth of computing power. You can install only a little bit of some clients, some servers, and can keep on growing it later on. Flexibility, possibility to connect devices from various vendors. Many networks like TCP/IP kind of network connects all sorts of operating system and devices. Powerful communication medium promotes cooperation among the far-flung group. So that is why I would like to have networks as far as industry is concerned. But what is there in the networks for us, we people? Well, as far as we are concerned, access to remote information is one of the major advantage of networks. We can handle finances, we can do online catalogs, online newspapers, online digital library, online information. All these things are reality in today's sense. Person-to-person communication. In what form? You can send emails to somebody. You can even organize virtual meetings. You can have news groups, chatting, all those kinds of things are possible. Interactive entertainment. Games like hide and seek are there. Flight simulators, fighters, all these games are available. But one of the main thing which network opens for us are the social issues. And most of the time when we talk about internet technology in the context of network, these social issues become more and more significant. Are we hurting somebody when we are sending our messages? Are we doing bad things onto the network? Now those are social issues. Those are the ones which basically are going to be major issues in the future. And we as a community has to stop all wrong things onto the networks. We are the people who can do all good things, make it one of the most powerful technology of the future. Now, what are the approaches of network communication? If I am talking about networks, how do the network communicate? How the information is passed? There are two basic approaches. One is called circuit switched, which is connection oriented. It is something like what you do in your telephone. A call setup time is taken. It has a guaranteed capacity. However, circuit costs are fixed and they are independent of traffic. So in circuit switch, it is something like your telephone based system where circuit setups take place. In a general network, normally this kinds of a thing is not acceptable, that you make a path. After all, many paths are there and they are being shared by many users at the same time. There is a very heavy traffic. You must be knowing the internet kind of a thing where such a heavy traffic is there. The circuit switching is not possible. So what do? You do something called packet switching. Now packet switching is data is divided in packets that are sent on high speed inter-machine connections, Packets are reassembled at destination. Multiple communications among computers can proceed concurrently. This is the most important advantage. However, not a guaranteed capacity. Sometimes you fail to get a particular page and second time you refresh it, you get it. Motivation, low cost, sharing of resources, good overall performance. Therefore, most of the networks do prefer packet switching. One more term which goes with the networking is services and protocols. Now what is service? Service is a set of operation that a layer provides to the layer above it without revealing its implementation. What is a layer? Protocol is the implementation of these operations and is the set of rules governing the format and meaning of the data exchanged by the peers in a layer. In both these definitions, what is the term we are using? Layers. Now let us look into ISO OSI model, reference model, which basically talks about these layers. OSI has designed 7-layer model, whereas TCP/IP model is just a 4-layer model. We have physical data link, network, transport, session, presentation and application layers in OSI, whereas network interface, internet, transport and application in TCP/IP model. Whenever we talk about a service, physical layer offers a service to data link layer. Data link layer offers a service to network layer, and so on and so forth. A lower level layer offers a service to higher level layer. For example, data link layer may be offering a service like reliable communication of data to network layer. Whereas protocol from physical to physical, another physical layer, there will be a way of communication of information. That's a protocol. From data link to another data link layer of another computer, that's a protocol. So this is how you distinguish between the services and the protocol. Now let us look into these layers in slightly more details. The physical layer. It is concerned with transmitting raw bits over a communication channel. Basic issue is that a transmitted 1 bit is received as 1 bit and not as a 0 bit. The decision issue here deals largely with mechanical, electrical and procedural interfaces and the physical transmission media. So these are the key issues. Typically related question which you ask about the physical layer happens to be how to represent one electronically, optically in the context of optical fiber cable today. How many microsecond a bit lasts on a channel so that it can be received reliably. Whether transmission may proceed simultaneously in both direction, duplex, half duplex, full duplex, okay, simplex, these are the terms. How the connection is established and terminated, okay, and how are the networks connected. So all these issues basically boil down to the physical layer. Some of the related concepts which we talk about in the physical layer happens to be analog and digital signals, the transmission media such as optical fiber, UTP, all that, multiplexing, how you multiplex data onto the same cable, simplex, half duplex and full duplex in both the direction. Simplex is one direction, half duplex in each direction but one at a time, full duplex in both the direction at the same time. Modem is a modulator demodulating device which is commonly used by us. The second layer happens to be the data link layer, which provides reliable transfer of information across physical layer. So physical layer just passes the data. Reliability comes from data link. It sends block of data frames with necessary synchronization and error control. So error control and related things are built into it. What are the key issues related to the data link layer? It identifies devices onto the network, various devices which are available. That means some kind of addressing issues will be involved. Controls and possibly correct errors. So error correction is built into it. All CRCs are built over here. Control access to the network medium. Who is passing information? It is control over here, and controls data flow. What direction, how it is to be passed, when there is a congestion, what actions to be taken. All those issues are dealt with this particular layer. Network layer, controlling the operation of communication network. So communication network is there, which is there provided by the data link layer. How to control these operations? Concerned with how data packets are routed from source to destination. Provides independence from data transmission and switching technologies, which are taken at data link layer. So these are, gradually you will find the services are becoming stronger and stronger, better and better and closer to what you have. The issues mainly is the addressing scheme of network may differ, various networks, so how to handle that thing. Packet size may be different for those networks, so it is the network layer which is going to take care of those things. The protocol may be different. Even the two networks may be following different protocol. So it is the network layer which has to take care that the protocols, the trans protocol things are taken care of. Network layer allows heterogeneous networks to be interconnected. So in nutshell, a network layer is allowing us to connect to heterogeneous network. Above network layer is the transport layer. It provides reliable transfer of data between endpoints. So from here source and destination are the important and not the intermediate points which may fall into your path. That is, I mean, looking at from this particular example, suppose you are going from, your train is from Delhi to Bombay, then these are two endpoints. Okay, the below three layers, that is data link, physical and network layer, they used to worry about each and every station in between, which is falling onto the path, all the stations. Whereas this transport layer will talk about only Delhi and Bombay. All those intermediate stations will be taken care of by the other bottom three layer. Provides end-to-end. That is what end-to-end is. Error recovery and flow control. Many hosts are multi-programmed. Multi-connections entering or leaving each host. So you can get multiple connections at the same time. Next is the session layer. It allows users at different machine to establish a session. It establishes, manages and terminates connections, sessions between cooperating operations. Now this particular layer is not commonly used. The presentation layer basically provides independence to application processes from differences in data presentations. That is also not commonly used. What is used is application layer in most of the implementations. It contains the logic needed to support various user applications, also provides distributed information services. Examples are file transfer among computers, having different file systems, having different file naming, conventions, different way to represent text lines, etc. So there are many examples which may exist. We'd like to see some more examples. Let us look into slight details about the TCP reference model. Now the bottommost layer in the TCP reference model is the network interface layer. It corresponds to physical and data link layers of OSI model. So nothing new about it. Responsible for transmitting datagram over a specific network. Datagram is the basic unit which is transferred onto a TCP IP network. Protocol is not defined and varies from host to host and network to network. So this protocol is dependent and not ever being defined. But what is defined in TCP IP is the internet layer. What is the internet layer? It permits hosts to put packets into any network and have them travel independently to the destination. Major protocol in this particular category is IP, the internet protocol. Now what is IP? The internet protocol specifies how a packet is formed, that is IP datagram packaging. So how do you form a packet? From a given message, you want to send an email. Ultimately at the level of IP, it will be converted into a datagram or a packet. Defines the address scheme that defines a unique number to a computer. You are sitting at a source. You want to pass information to a particular destination. Unique numbers are associated with it. 32-bit addresses, IP addresses. Okay, what are those? IP makes an interconnected set of networks and routers operate like a single large network. And that is what TCP IP or your internet is. IP chooses path that lead to datagram destination, routing and congestion control. So it does a lot of activities as far as routing is concerned, congestion control is concerned. Let us dwell about the addressing part a little bit more. Addressing an IP. Each host on a TCP IP network is assigned a unique 32-bit internet address which is used for all communications with that host. So 32-bit internet addresses are there, okay, which consist of a pair. It is called net ID, which identifies the network, host ID, which identifies the host on that particular network. Let us try to look into some typical classes of addresses which are there in IP. They are Class A addresses, Class B and Class C. Class A basically they start with first byte as the net ID and all remaining bytes as the host ID. So what you see over here, if an IP address starts with a 0, okay, this is Class A address. What is the typicality of Class A addresses? The range is 0.1.0.0, okay, and varies till this particular address. These addresses are given only to handful of networks which are having more than 2 to the power 16 hosts, and some of them were Intel or IBM, those kinds of initiators were given these kinds of addresses. Class B addresses basically start with 10, and first 2 bytes are allocated for net ID and remaining for the host ID. These addresses varies in this particular range, 128.0.0.0 like that till 191.255.0.0. These are for medium sized, moderately big networks. The third category of IP addresses is class C address, which basically are quite common in India, which starts with 110, that means 192.0.1.0 onwards till 233.255.255.0, given to networks having less than 2 to the power 8, 256 hosts. So whenever you go for some kind of an ISP, you are given 5, 10, 6 different internet addresses. You will find most of them are into class C category. The final layer which is there is the transport layer. In fact, transport and application layer are there. 2 main protocols are there in the transport layer, the TCP and UDP, the user datagram and transmission control protocol. What is the need of these 2 protocols? TCP is basically the protocols required for reliable communications. Routers may discard some of the incoming datagram due to overload, which is not known. IP does not detect missing datagrams. So this is the basic problem. TCP eliminates duplicate data, ensures that reassembly is in the correct order, resends lost datagram. TCP uses acknowledgement and timeouts to handle the problem of loss. So TCP is just providing a reliable thing onto the reliable communication, that your packet or your message, it's not packet now, your message is communicated, your EML message reaches to the destination completely, despite being bundled into packets, despite there may be certain losses of packet in between. Your message receives reliably to the destination, and this is the role played by TCP in TCP IP. As far as application layer are concerned, there are telnet kind of protocols, FTP, which is used for transferring files at various destinations. Okay, that is there. Domain name service is also another application, which basically the kind of addresses you have is not IP addresses directly. You deal with user oriented addresses. So those are resolved using domain name services. Then HTTP, on which your complete internet is based on, is this kind of a thing. Now let us try to wind up this particular session with another interesting thing, and that is hardware which is required for computer networking. Now what are the basic hardwares which you will be required in a computer system if you want to network? Well, the diagram tells us some certain numbers. There is a hub or concentrator somewhere in your network. There are certain repeaters if you are connected through a long distance. There are certain bridges which connects 2 different networks which are there. There are certain routers which may be connecting to an entirely internet or different network altogether. Let's try to look into these a little bit more. What is the first thing which we have in our computer if I want to be connected with the network? It is network interface card. What is network interface card? It basically is a card which is fitted into your system, interfaces a computer board with the network medium. Most NICs, network interface cards, are designed for a particular type of network, protocol and media, through which some can serve multiple networks. Okay, so network interface card is what is fitted into your network. I think most of you must have heard 10 to 100 Mbps kinds of network card which are there for Ethernet. The second thing is repeater, which basically communicates, amplifies the information, which is the information is getting tapered off, again gets re-amplified and passed further. 2-port electronic devices that amplifies or regenerates the data signal in order to extend the transmission distance. Available for both analog and digital signal, it is used extensively in long distance communication. So repeater is another kind of device which is used. The third device is called bridges. Bridges basically connects two different segments of LAN. More sophisticated repeater with logic capabilities that filter packets between two network segments. Filtering means only those packets will be passed further which are meant for other LAN segment. A bridge will forward and discard an incoming frame based on the address of that frame. So that is the basic logic which I wanted to propagate to you. Hubs. Now hubs are the key thing which you will find in any organization. What is a hub? It is a multi-port repeater. Okay. Major function is to replicate data it receives from one device attached to it and communicates to all. Hubs differ in number of devices that can be connected, length of wires that can transmit on, type of media they support. You can visualize in this particular hub that data first initially comes from one particular terminal and then is broadcast to all other. Now this is the property of the hub. Okay. The next thing is called switches. Switches are much faster version of hubs and they communicate various different segments of network. Switch is a device used to link several separate LANs also and provide packet filtering between them. So whatever packets which have to be filtered are meant for this particular network, and if you are being passed from here, they will be filtered for this network and not all the information will be broadcast. Packets are filtered by switch based on the basis of destination address, that is the key. Switches can also support numerous transmission simultaneously. So switches are basically meant for numerous transmission. That's how they are very, very fast switches. They increase the speed and they are quite expensive too. Now this is in general are devices which are being utilized in physical network. Now routers are logical devices. Now what does router do? Router is a device that forward data packets from one local area network or wide area network to another. Routers read the network address in each transmitted frame, makes a decision on how to send it based on the most expedient route, traffic, load and all those kinds of devices. So this kind of a router can be built onto a computer in bit or specific devices can be utilized. Gateways are also in the similar category. A gateway is a computer that performs protocol conversion between different types of network or application. Gateway function at layer 4 and above in the OSI model. So gateway basically operate at point to point or end to end kind of communication. Finally, it is the modem. What modem do is, it is a modular demodulator which we commonly use at our house. Modem converts digital data from a computer to analog signal that is used by voice communication networks such as telephone system and vice versa. It sends it across and at the receiver end the reverse process is conducted or reverse process is carried out and it is received in the other way round. So this is in nutshell are some of the devices which are used in a network. Thank you.